Write an expression. Oh, this isn't bad. 6 more than twice a number. Yep. So she said 2x plus 6. Were any of you thinking 6 plus 2x? Doesn't matter. Both fine. Perfect. Beautiful. 6 less than 4 times a number. Now the order matters. What did you say? 4x minus 6. Beautiful. 4x minus 6. When it's 6 less than, guys, it's got to be at the end. Got to be minus 6. Okay? So far, this is simple. Let's see what's next. 24% of a number. 24% of a number. What? No, but that's a good thought. 0.24x. Remember that percents never, ever, ever show up as a percent in a problem. They always show up as a decimal. If you're writing an equation, your percent's going to be a decimal. And 24% means 24 out of 100, 0.24. In math, the word of, it says 24% of a number. Of always means times. So it's 0.24x or 0.24n, whatever letter you want to use. But of to the mathematician means multiply. Okay? Find the final cost of an item if the original price is X and there is a 15% discount and a 7% tax. Okay, now, here's what I want you to think about. Whatever it is I'm buying, this is how much it costs. There is a 15% discount. So in other words, it's on sale for 15% off. Now, what some of you are thinking about doing is saying, okay, if it's 15% off, I can multiply it by 15% or 0.15 and then subtract that, and that's how much I would owe. Does that make sense to you? But there's an easier way to do it. That will be hard with an X, what I just described. I want you to think about this. If I am not paying 15%, if they're taking 15% off, how much am I paying? 85%. So I am paying 85% of the price. So I am going to multiply this by 0.85. That 0.85 is 100% minus 15%. Because the 15% is coming off the price. I'm subtracting it off the price. You understand where the 0.85 came from? Because now I'm going to do the same thing. Now on top of that, I have to pay a 7% tax. Now, the difference is the tax does not come off. The tax gets added on. So I'm going to multiply by 100% plus 7%. What decimal is that? 1.07. So the way the cash register does this, it doesn't multiply and subtract and then multiply and add. That's not the way it works. The cash register says, okay, I'm taking off 15%, so I'm multiplying by 0.85. I'm adding on another 7, so I'm multiplying by 1.07. And that would be the way you would set the problem up. Does that make sense?
Yeah.
Okay.
I wasn't used to
Okay. So now, on to the next problem, E. Find my salary after a 7% raise. So this has never happened, but I would be so happy if it did. if some administrator walked in and said, Mrs. Ford, we're so happy, we're gonna give you a 7% raise. How would I calculate my salary in one step? I don't wanna do it in 2 steps. How would I do it in 1 step? Well, guys, same way I added on the tax. I'm gonna take my salary times 1.07. Cause aren't I gonna get 100% plus an extra 7% of my salary? What if they walked in and said, you know what, you're doing a terrible job, we're gonna take away 7%. Then it'd be X times 0.93, because that would be 100% minus 7%. What I want you to remember with these problems is, you always start with 100, and then you either subtract the percent if it's a discount or something, or you add the percent if it's a add-on. Got it? We're never gonna multiply by 7%. Not doing it. We're either doing 100 plus 7 or 100 minus 7, depending on whether the problem is growing or shrinking. Okay? Pay attention, guys. I know it's hard. Here we go. Actually, I don't know that it's hard because I find this so fascinating. The area of a rectangle, I want to find the area of a rectangle, and I know the width is 3 less than the length. So the width is 3 less than the length. Tell me how to label that rectangle. So what do you want to have be X, this or this? Top one's X, okay, and then what would this one be? X minus 3. Does that fit? 3 less than the length? Looks perfect. Then how would I find the area? The question says, what would the area look like? How do you find the area of a rectangle? Length times width. Wouldn't that give me the area of the rectangle? Now I want the perimeter of a rectangle. So another rectangle, but now I want the perimeter, whose length is twice its width. The length is twice the width. So what about that? So one of them will be X and the other one will be 2X. And then how do I find perimeter? Add up all the sides, and of course if that's a 2X, this is a 2X, and that's an X, right? So adding them all up would be X plus 2X plus 2X, which is just 6 X's. Here's another one of these. The final cost of an item whose original price is X, and there's a 20% discount and a 7% tax. Alright, so here's my original price. I have a 20% discount, and I have a 7% tax. So what am I gonna multiply by if there's a 20% discount? 0.80, because it's 100 minus 20. And then what am I gonna multiply by if I have to pay 7% tax? 1.07, because it's 100 plus 7. Now we're actually going to do some problems. Your favorite teacher received a 3.2 salary increase. Her original salary was 1, 2, 3, 4, 5. What is her new salary? know my salary is 1, 2, 3, 4, 5. And I'm gonna multiply it by something that reflects a 3.2% increase. What will that decimal be? 100 plus 3.2 would be 32 would be awesome. Because what would 32 be? A 32% increase? That would be awesome. 0.32. Yeah. Remember, percents are hundredths. So that's 0.032. Okay. Just a second. All right, so I'm gonna go ahead and type that in my calculator because this one I can actually get a number for. 1, 2, 3, 4, 5 times 1.032. My new salary will be $12,740.04. You're thinking, gosh, Miss Ford, that's not very much money. That number right there is about double my starting salary at Cathedral. I am not kidding. Yep. Okay, last year, a pre-cal book cost $89.50, and this year it costs $97.75. Find the percent of increase. Oh gosh, how many of you had Mrs. Field for Algebra 1? How many of you had Needy in the summer before Algebra 1? We did these by bazillions, people. Percent of increase. Who remembers? Someone remember how we do percent change problems? It was a long time ago. So it's the difference, Sean, thank you. It's the difference over the original. This is how you find percent change. So whether it's increase or decrease, doesn't matter. If something is changing and you want to know the percent by which it's changing, you're going to do the difference over the original. So for this problem, the difference is, I'm embarrassed that I have to type this in on my calculator, but I am. 825 is the difference. Would everybody agree with that? And then the original value is the first number, which is 89.50. So I'll just do that division on my calculator, and I get a 9.2% increase. So we find the difference in the two values, and then divide by the original. And difference means what? Add? Subtract. Difference means subtract. So we find the difference and then we divide. Okay? C is the same thing. A car that was worth $23,456 originally is now worth $18,765. Find the percent of decrease. So what do we need to do? Subtract them. So 2, 3, 4, 5, 6 minus 1, 8, 7, 6, 5. I got 4691. And then what do I divide by? The original, which is the 23,000 number. So it's about a 20% decrease. I mean, it came out to be 0.19999, so I'll say 20% decrease. Okay, let's go. Let's get this page done, this section done, and we can start reviewing for a test. All right, so D says a square of side X is cut out of each corner. The sides are folded up to form an open top box. Oh my gosh, have we done this before? Don't you guys remember making your boxes? We haven't done this problem yet? Oh, I thought we did. But that's because I'm old. Yeah, so what we're gonna do is we're gonna make a box. All right, so when everybody get a piece of paper, sheet of notebook paper. If you don't have one, borrow one from a friend. You need a sheet of notebook paper. Regular piece of paper.
So can you do it? You can do it. Why not? What a guy. Good guy.
All right, so we got a piece of paper. All right, quick ready. We don't have time for a bunch. Here's what we're gonna do. You gotta look it out of your notebook. We're gonna tear it up. We're gonna make sure all the pieces get put into the recycle thing. We're not going to. Dave, did you stop what you're doing, Dave? Or do this too? All right. So what I want you to do is tear, and we're not measuring, so you're gonna do the best you can. Tear a square out of a corner of your paper. Whatever size you want. Don't make it just like mine, that'll be boring. Make it whatever size of square you want. And then rip the same size squares out of every corner. So you're just gonna take every corner, cut a square out from it. And you want them to be close to the same size. They're not gonna be perfect. We don't care. No one's grading the art project. We're just trying to get an idea for what's going on in the problem. So make your squares as close to the same size as you can. When you get the squares torn out, take these little flats that you have and fold them up. So fold your flats up. And what that's going to give you when you do that is a nice little box. So fold up your flats after you get all your corners ripped out. Every corner, and take same size square out of every corner, close as you can. It won't be perfect, make it as best you can. Fold up the slats and you got a box, right? Now, as people finish up, I want you to look at each other's boxes. Because basically, you all started with the same size piece of paper, and yet your boxes look different. Right? Look at this one. Whoa, look at this box. Right? They're all different. So let's suppose that you had a really nice math teacher, just suppose, imagine it, and she had brought brought in a huge bag of M&Ms, and she went around the room, and she filled everybody's box with M&Ms. Do you think every box in this room would hold exactly the same number of M&Ms? No. No, because everybody's box is a little different and will have a little bit different volume. What made that happen? What made my box way different than Foster's, different than Josh's? What made that happen? The size of the squares that you took out, right? So if we look at the question, it says we have a 12 by 14 piece of paper. So this is 12 by 14. And we are going to cut these corners out, which is exactly what you just did. And we're going to fold up the flaps to make a box. We want to know how big these corners have to be to find the maximum volume. So in other words, you want to cut out corners that make your box hold the maximum number of M&Ms. Okay? All right. So first thing, this is a picture. Everybody understand the picture? It's what you just did. So now we want to write the equation for the volume of the box. Who remembers how to find the volume of the box? Length times width times height, right? So think about your own box. Which I don't know what happened to my box. All right, think about your own box. Don't look at it, yes. The length of the paper, the original paper, was 14, let's say. But what did I do? This was the original length right here, right? From here to here was the original 14. Didn't I cut a chunk off this and a chunk off this? So now my new length is only this far. How would I express that? How would I express the length of my paper now? 14 minus x? 2x. Because didn't I take an x off the top and an x off the bottom? So this is going to be 14 minus this minus this. So 14 minus 2x is right here. What about the width of the paper? What's this going to be? 12 minus 2x. And then what about the height of the box? How tall, when I fold these flaps up, how tall is that? Isn't that just x?
Yes.
There is your equation for the volume of the box. Now, I want you to put a star by that, because even if you do not understand a thing about what I'm talking about, you're going to do a box problem. I guarantee it's on the test. I guarantee it's on the semester exam. You're going to do a box problem. And every single one of them is set up exactly the same way. This one is 14 minus 2x, 12 minus 2x times x. If the paper had been 20 by 30, it would be 20 minus 2x, 30 minus 2x times x. It's never going to change. Whatever the dimensions of your paper are, go here. Everything else stays the same. Got it? Every box problem you do. Now, that's the equation. The next question says, what's the domain? Now, for domain, I'm talking about the x's, and I'm thinking about my box, and I'm wondering, how big can x be? Can x be think about your paper here. Can X be 100? Could I rip off 100 inches here? Why not? Because it's only 14 by 12, right? So can you figure out what would be the biggest that I could cut off? What would be the biggest X value that I could cut off? What'd you say? 14? So I want you to think about that. Could I cut a 14 off here and a 14 off here? No, because the whole thing's only 14, right? So I can't take 14 here and 14 here. That won't work. Another thought? 7? Could I take 7 off there and 7 off there? Well, that, if I did, I'd have nothing left. So that would be like the absolute upper number. I'd have to be less than 7. But that won't work up here, kids. Can you take 7 here and 7 here? No. 6 and 6? Your domain is 0 to 6. Your domain, your X, the size of the squares that you cut out, has to be bigger than 0. It can't be negative, so it has to be bigger than 0. And it has to be less than half the smallest dimension. So the smallest dimension of the paper is 12. You can cut up to 6 off each side. If you have 12, I can take 5.9 and 5.9. Now that's not going to leave me with very much, but I can do it, right? 5.99, 5.99. Anything up to 6 can come off. Now, we tried 7, which is half the larger dimension, but that doesn't work with 12. So that's why you've got to take half the smaller dimension. So it's 0 to half the smaller dimension. No, we want the domain. So the domain is all the possible X's. So the only answer is 6, 0 to 6. Those are the possible X's. Now, could X be 4, Olivia? Absolutely. I don't know what X actually is. I know it's in between here, but it could be 4, or 5, or 2, or 1.6. That's what we're going to figure out in the next part of the problem. Okay? So, every box problem you ever do, dimension minus 2x, dimension minus 2x times x, every time. The domain of every box problem you ever do, put x between 0 and half the smaller dimension.
Does it matter the order?
Yes.
Right in parentheses?
That'd be 0 to 6.
No, I'm talking about.
No, the order of the parentheses doesn't matter. Nope, not a bit, not a bit. Now, I want the maximum volume. So we're going to get our calculators out. When you take your Calc 1 class, your first calculus class, you will learn how to do this problem without a calculator. We are not going to do this. We are going to use our calculator. So everybody's got your calculator out, and everybody is listening carefully to what Mrs. Ford says, because I am not going to come help you. If you type what I tell you, it'll work out perfectly, I promise. All right? So the first thing I'm going to do is go to my window. I'm going to go to window. Okay? And right here is X min and X max. So in window, you're going to put 0 for X min and 6 for X max. For Y min, put 0. Now I'll tell you why, but again, you're always going to put 0 in a box problem. So if you don't understand what I'm saying, just put 0 there every time. Y is the volume. And whatever the volume is, I know it can't be negative. So the smallest it can be is 0. So Y min is 0. Y max is the answer to the problem, and I don't know what that is. So I'm just going to guess. Let's pick a big number like 300 for Y max. That's just a guess. I might have guessed wrong, and we'll talk about that, and I'll guess again. It's not the end of the world.
Wait, what are we doing for 1 min?
0. Pay attention. Zone in. When you're basketball practice, Delaney doesn't repeat himself. You're listening. You listen to me the way you listen to him. All right. Now, go to y equals. Y equals, we're going to put in our equation. And this is what we're going to type in. The good news is you do not have to multiply it out. So parentheses, 14 minus 2x. And remember, x is your variable button. That's where your x is, right where my fat little finger is. That's your x button. And then close the parentheses. And then more parentheses, 12 minus 2x. And then an x. And then hit graph. Remember when we guessed? If you see on your calculator a hill, then we guessed right. If we don't see a hill, if we see it go up and then it comes back down, then we know we didn't see the hill, so we have to make our number bigger. Instead of 300, maybe 400. But I can see the top of the hill, right? That's the point I want to find. So I'm going to press second, calc. Look where my fat little finger is pointing. The actual button says trace, but above it says calc. So second calc. Look at that list of junk we have there. We want maximum. Problem says find the maximum. So click down to maximum and hit enter. Now the cursor pops up, flashing on your screen. Use your arrow button and move the cursor over here somewhere. There is no one place. Just move it over here. So the cursor is over there. I'm using my arrow buttons. Press enter. Move the cursor to the right. So now use your arrow buttons and move it over here. Press enter. Now, those of you with the new calculators, did your calculator actually put a couple of lines in for you? Yeah. Those lines can be anywhere as long as the maximum is in between them. That's the key. You guys with older calculators like me, we don't have lines, we have these little things that look like this. As long as the point that you want, the maximum, is between those, it's good. It doesn't matter where you put them. Move your cursor to the point where you think, just get in there somewhere. In between your lines, in between your arrows. Get in there somewhere and press enter. And on the screen, it will say your maximum is 2.148 and 160.584. How many of you have a calculator that actually says the maximum is that right down there? How many of you got that? Good, you guys are on the right track. The rest of you weren't following directions, but don't worry, there's another one. We're going to do another one. Now, this is the X value, this is the Y value. The question said, find the maximum volume. Okay? What do you think I want? The X value or the Y value? Remember when you set up your equation, do we want X or Y if we want the volume? Okay, did X stand for the volume? What did X stand for? The corners that you ripped out? Okay, that's not the volume. Did Y stand for the volume? Length times width times height? So the maximum volume is 160.584 cubic inches. All right, I want everybody right now to get up and deposit your boxes in the recycle, please, including all of your little squares. And then we're going to do another problem. So we're getting up, moving around. Getting ourselves focused. And we're going to do another box problem. Alright, so look around the floor. If there are scraps of paper on the floor, you're going to throw those away. We're not going to leave the room a mess for the cleaning crew. Okay, so here we go. On to problem number E, letter E. Now our paper is 20 by 24. We're cutting out corners that are X inches square. We have the same exact question. Write the equation for the volume of the box. All right? Tell me what this equation is going to be if the paper is 24 by 20. 20 minus 2x. 24 minus 2x times x. Now again, in my heart, I hope you all understand that. But if you don't, just memorize it. The volume of the box is going to be dimension minus 2x, dimension minus 2x times x. Period. Never going to change. Now, tell me about domain. I know x is going to be between two numbers, and I know that one's always 0.
0,
0 to what?
10.
10. And you're right. Why is it 10?
Because it's half the smallest.
Half the smallest dimension.
Does it matter what order we put like the 20 and 24?
No, somebody already asked. It has to be the number minus 2x, but these two can be flip-flopped. The order of the parentheses doesn't matter. But don't do 2x minus 20. That will be wrong. It has to be 20 minus 2x. All right, now we're going to find the maximum. So first thing I want everybody to do, and if you weren't doing this before, please do it now. Because we're not going to do this again. You're going to have to know how to do this. So go to window, and this time, we're going to change our window, right? So x min is still 0, but now x max is 10. Y min is still 0, and just for fun, let's leave Y max at 300. Okay, let's just leave it there and see what happens.
So what about XSCM?
Make it 1. We don't change those numbers, they should just be 1s.
What's
What?
X
X min's right here. That's X min, that's X max. Okay, now let's go to Y equals, and let's type in our new equation. So you're going to type in your new equation with the parentheses, just like they are, using your X variable button, which is right under the mode button. That's how you get X in your equations. As soon as you get it typed in, go ahead and hit graph. Now, what's our objective? What are we looking for? What do we want to see? We want to see the top of the hill. This time, did you see something that looked like this?
Yeah.
So remember when we left that guess at 300? It's not big enough. So change it to something. What do you want to change it to? Go back to window and change, okay, I heard 600. Change Y max to 600. And press graph. Still not big enough, is it? So back to window. Y max maybe 1,000.
Oh, yeah.
Did 1,000 work?
That's big enough.
Okay, now, there are other numbers that would have worked. There's nothing special about 1,000. I just knew it had to be bigger than 600, right? So as long as you see the top of the hill, then we have no issues. There's no magic number. Just guess Y max until you see the top of the hill. All right, so everybody should be looking now at a hill. And we are gonna find the maximum. Right? So how we do that on our calculator, we press second calc. It says, it's the trace button and it has calc written above it. That's the menu we want. That's why we press second that button. In this problem, we want a maximum. So we're just gonna go down to option, for me it's 4, I don't know what it is for you. We'll go down to where it says maximum and press enter. Now, what happens as soon as you press enter? You got your picture back, but it's got a cursor on it.
Yeah.
Okay? Now, you need, and the calculator's guiding you through, it's saying left bound, you need that cursor to be over here somewhere. So wherever the cursor is, move it so it's over here somewhere. There's no magic spot, just get it over here somewhere using your arrow buttons. And as soon as you got it over there somewhere, press enter. Those of you with the new calculators are going to get a line. Those of you with the old calculators are going to get a little mark like that. Okay? Now what do? Look, the calculator's saying to you, where's the right bound? Okay, move the cursor to the right. So move the cursor now so it's over here somewhere. Anywhere over there. And press enter. Those of you with a new calculator now have a line there. I now have one of these little deals here. If you want to get the right answer, your maximum point has to be between the lines or between the arrows. So that's why you set one over on the left and one over on the right. Now, move the cursor, using the arrows again, move the cursor till it's in this area right here. In the area of the maximum. And press enter. Who got an answer? Down here at the bottom it says maximum x equals, well, 3.62, and y is 774.16. Now, there's one answer. We're not going to be off. So if you are trying to trace, instead of using second calc, you're gonna be off, you've gotta do the process. Second count, maximum, and then we'll all get exactly the same answer. What was the question? Find the maximum volume of the box. The maximum volume of the box is 774.16 cubic inches. Y is the maximum volume of the box. Y is the volume. If I said to you, take out a new sheet of paper and make the box with the biggest volume, then this number tells you how big the corners are that you have to rip out. That's what this number is. If you want to make the best box, your corners are going to be 3.62 inches square. Okay? All right. We're going off script here for a second. I'm going to give you another piece of paper, made up piece of paper, and I want you to work with your partner and come up with the answer to the question. So we're going to do everything exactly the same. We're going to build a box. We're going to find the maximum volume. And the paper this time, the paper is going to be 28 by 30. So, work with your partner, hurry up, do it quickly. We're not making, no, we're not actually making the paper. Okay, we are just doing this problem. So you may need to do it on other paper. It's not in your notes, we're doing this as a separate problem. Right there, the paper is 28 by 30. So write your equation, find your domain, and find the maximum. It's 28 by 30. Just to make sure we're all pointing in the right direction, what equation are you typing in?
28 minus 2x. 30 minus 2x. With x.
Perfect. So stop and look. Is everybody putting in that equation?
Yeah.
That's the equation. Now, when you set up your window, which I hope you did, because that's kind of the secret to the whole thing, what domain did you use? X was between 0 and 14. Now you should be getting a maximum here pretty soon if you're typing in second out. Move your cursor around. Left, enter. Right, enter. In the middle, enter.
How much
'Cause I sent it to
Alright, we're getting close to being out of time. So, no. Oh, this is. Yep. Okay, so the answer we should come up with for our maximum volume. By the way, did you have to change your Y max this time? Yes, because I don't know what we had originally, but it wasn't near big enough. So you changed it, you saw the top of your bill. Your X is 4.82, and your Y is 1801.76. So when we write our answer, maximum volume is a unit cube. So in this case, it's inches cubed. Please get in the habit of labeling your answer. Why is this on your list?